we have a large right triangle and one surprisingly clever clue. Can you use it to find the exact length of a hidden perpendicular? Let's see. We have right triangle ABC. The right angle is at point B. The vertical side, AB, is exactly 24 units long. Along the bottom base, BC, we have a point Q. The short piece from B to Q is exactly 7 units. From Q, we draw a line straight up to the hypotenuse AC, and it meets the hypotenuse at a perfect right angle. Let's call that point P. Our mystery is the length of QP. We'll call it X. But here's the crucial clue. Point P divides the hypotenuse exactly in half, so AP and PC have the same length.
Now, let's add one simple line to the diagram. Draw a straight line from A down to Q. This creates a smaller right triangle on the left, triangle ABQ. We already know 2 of its sides. AB is 24 and BQ is 7. So we can use the Pythagorean theorem. AB squared plus BQ squared equals AQ squared. That gives us 24 squared plus 7 squared equals AQ squared. 24 squared is 576. 7 squared is 49. Add them together, and we get 625. So AQ squared equals 625. The square root of 625 is 25. Therefore, AQ is exactly 25 units.
Now comes the clever part. Look at the 2 smaller right triangles along the hypotenuse, triangle APQ and triangle CPQ. They both have the same side, PQ. They both contain a right angle, and our crucial clue tells us that AP equals PC. So these 2 right triangles are congruent. In other words, they are exact mirror image twins. That means their hypotenuses must also be equal. So AQ equals CQ. And since AQ is 25, CQ must also be 25. Now we know 2 sides of the giant right triangle ABC. AB is 24, and BC is 7 plus 25, which is 32. Let's use the Pythagorean theorem one more time to find the hypotenuse AC. AC squared equals 24 squared plus 32 squared. There's a nice shortcut here. Both 24 and 32 are multiples of 8, so we can write this as 8 squared multiplied by the quantity 3 squared plus 4 squared. And 3 squared plus 4 squared is 25, which is 5 squared. So AC squared is 8 squared times 5 squared. That means AC is 8 times 5, which is 40. So the entire hypotenuse is exactly 40 units. And remember, point P divides the hypotenuse exactly in half. Therefore, AP is 20, and PC is also 20. We're almost there. Look at the smaller right triangle, CPQ. We know its hypotenuse, CQ, is 25. We also know one leg, CP, is 20, and the other leg, PQ, is our mystery length X. So one final use of the Pythagorean theorem, X squared plus 20 squared equals 25 squared. That means X squared plus 400 equals 625. Subtract 400 from both sides, and we get X squared equals 225. Take the square root, and we finally get X equals 15. So the exact length of the perpendicular is 15 units. And the really satisfying part of this puzzle is that everything starts with those two equal pieces of the hypotenuse. Once we recognize the two smaller triangles as congruent, the rest of the problem almost falls into place. A few Pythagorean triples, one clever congruence, and we arrive at 15.